Hello, this is Mr. Gusakuma, and today we are going to tackle the fifth topic of exponential functions, growth versus decay. This is a fairly simple exercise in which all you need to do is identify whether this function is going to be growing and trending upward as time goes on, or decaying and trending downward as time goes on. The key number to look at for these problems is the base of the exponent. So if you recall, we had a starting value for this example that is 1/3. It's the number being multiplied by. That was the principal amount. That was the letter A. When we talked about interest, we have a starting value and we have a base to the exponent, the number that is underneath the power of x. So in this case, we have a starting value of 1/3, and the important number for growth or decay is 2/9. That is the base, the number that is underneath the exponent. And the rules are very simple. If that number is larger than 1, you have an exponential growth function. So once again, bigger than 1 is growing. And if that number is a fraction that has a value between 0 and 1, then you have an exponential decay function. It is important to note this number cannot be negative, or else some weird things happen and it does not follow our exponential pattern. And it is also important to note that some fractions, for instance, if this was written as 9/2, would have a value over 1 and thereby be growth. But this problem, 2/9, is a decimal equivalent that is between 0 and 1, so this is an example of decay. The last bit of information you may need to successfully complete this set is the general shape of growth and decay functions. In this case, example A, or our answer choice A, looks like exponential growth. It is going up more quickly as we go to the right. So we read graphs the same direction we read words, starting on the left and going towards the right. This graph is going up. A is growth. And comparison to example choice B, that is decay, as we follow this graph from the left to the right, this graph is going downward. Now it does look like this flattens out. This graph has what is called asymptotic behavior. It gets very, very close to being a line as it flattens out and headed towards the right, but it's not. It's actually continuing to decrease just at a smaller amount because there's less of the function there as the time goes on. So to answer this question, again, we have a starting value of 0.6, that's my A, my initial value, the number multiplied by, and the important value for this problem is the base of the exponent, which in this case is 3.2, and 3.2 is greater than 1, so this must be, I'll let you figure that out on your own. Good luck.